Hello and welcome to our video lesson 464 and 65 properties of rectangles, rhombi, and squares. Rhombi is just a plural way to say rhombus. You could say rhombuses too, but rhombi is also correct, and that's what I'm going to use. And we're going to learn a lot about these properties today. We've talked about these briefly before the semester ended. We're going to talk about it more now. And we're going to fill in eventually a family tree of quadrilaterals. Technically, all of these are parallelograms. So let's start this off. If we have a parallelogram, that just means the 5 properties qualify. First one, if you remember, we have both pairs of opposite sides are parallel, okay? And all of these should sound familiar. You should have these, you should ace this test or the quiz. But we can't forget these. Both pairs of opposite sides are also congruent. So those have to do with our sides. We also have 2 that have to do with angles. Both pairs of opposite angles are congruent. We also have consecutive angles are supplementary. And last but not least, the one that's completely on its own, diagonals. Diagonals bisect each other. So these are the 5 properties of parallelograms. We've talked about this. You should know these by now. But when we talked about rectangles, rhombi, and squares, a rectangle is technically a parallelogram because opposite sides are congruent, opposite angles are congruent, and actually you don't have to copy this part down. You don't have to copy all of these things down. Diagonals will eventually bisect each other. Consecutive angles add up to 180. And we have opposite sides that are parallel. But that's neither here nor there. We're not going to talk about that into great detail. What I do want you to have here is this rectangle, and its probably most defining characteristic is that it has 4 90-degree angles. But that's not the only property. So first and foremost, let's actually do this. A parallelogram, and we're going to draw an arrow over to the rectangle because a rectangle is technically a parallelogram. All of these rules apply to rectangles, like we just talked about. But a rectangle also has its own rules. First rule for rectangles, as noted in the picture, is that all angles are right angles. Okay? And second characteristic is that diagonals are congruent. Okay? So this is in the diagram above. You can see that. And let's draw a separate rectangle here to show this. What this means is, sorry, I'm drawing this so small, that these 2 diagonals are equal to each other. So if I label this A, B, C, and D, we could say AC is congruent to BD. Okay? So that's all the characteristics for a rectangle. Rhombi, or singular rhombus, has its own set of characteristics, but it is still technically a parallelogram. Okay? So this is a rhombus. And its most defining characteristic is that all sides are congruent. But that's not the only property. So let's do this. First property, all sides are congruent. Okay. We also have this property, diagonals are perpendicular. So let's draw a separate rhombus, just like we've been doing with parallelograms and the rectangle to the left. If you draw a diagonal from one corner to the other on both corners, then we will have right angles all around in this intersection. That's what it means. Diagonals are perpendicular. They create 90-degree angles. They are all centered in the middle in the intersection of these diagonals in this rhombus. And then the last property specific to rhombi is that diagonals bisect opposite angles. Meaning, let's draw another rhombus. Doesn't want to draw. Let's try that again. Wow, that's terrible. One more time. My goodness. Let's draw this. Just do it on our own. So diagonals here. Let's do this in a different color, and let's make this a little bit thinner. Diagonals bisect opposite angles, meaning these two angles are congruent. These two angles are congruent. I'm going to put 2 ticks and 2 ticks. 2 ticks and 2 ticks. And the reason why I put it like this is because if you remember, opposite angles are technically congruent because of the property for parallelograms. And since they, if for instance, this was like 100 degrees, it would cut it into 50 and 50. Sorry, I should have done this in pink. This would also be 50 and 50 because opposite angles are congruent. This would also be 100. So hopefully that paints the picture. No. Take out these 50s. And we could see that they clearly they should bisect the angles. Okay. So those are the 3 properties for rhombi. And the last one we're going to talk about today is square or squares. Squares are a very specific parallelogram. Let's make this a little smaller. Its most defining characteristic is that it's technically a rhombus and a rectangle. We have 4 90-degree angles, or all of them are 90 degrees, and all sides are congruent. So technically, a square is a rectangle and a rhombus, and not the other way around. A square could be is always a rectangle, but a rectangle is not always a square. Okay, so a square has all of these rules. So I'm just gonna, you don't have to rewrite these. You could say, if you want to, you could say all properties of rectangles and rhombi, rectangles and rhombi apply. Okay, and if you want to rewrite all of these down, you can. It's not great. It's not important that you do, but you could say all angles are 90 degrees are right. You could say diagonals diagonals are congruent. And let's continue with diagonals. Diagonals are perpendicular. You could say diagonals bisect opposite angles. And then the last one, you could say all sides are congruent. Okay, those are 5 properties when you combine the rectangles and rhombi, and that's how you identify if it's a square, rhombus, or rectangle. So for instance, well, let's leave it at that for now. Okay, so here's our lesson for the day. Rectangles, rhombi, and squares. Be able to tell the difference between a rectangle and a rhombus, and if it eventually becomes a square. And don't forget, all of the properties for parallelograms apply to them all, even the squares. Okay? All right. So, with that said, thank you, and I'll see you in the next one. Bye.